Okay guys, a 15-minute video on transformations of exponential functions. So, hope you enjoy this. Here's your note. First things first, why don't you, teacher in charge, could you just pause it and let them copy this down? 'Cause it'll take a while. All right, so go ahead and pause that. And I guess I don't get paused though, so I'll keep talking. And we're back. How was that? Okay, so what's going on there? AC/DC is a rocker, but AKDC, A, K, D, and C, same as before. Okay, you have your A is vertical compression or stretch. If it's big or small, you flip it up or down. Okay, so we're looking at vertical stuff for A. We also look for vertical stuff for C, so we're going up or down, shifting up or down. And then we have K and we have D. K is horizontal compression, a horizontal stretch, and horizontal flip, and D is move side to side. So let's go through this real quick. Our base function is 3 to the x. So what we want to do is say what's happened to 3 to the x. And what has happened is that the whole thing is multiplied by -3. You can kind of ignore this here. Multiplied by -3. It's not on the x, it's on the 3 to the x, so it's on the function. So the function's 3 to the x. So therefore it's A, and it's -3, so 3 is vertical stretch, and the negative reflects the graph. Here we have 3 to the negative x, so we have a half. There's A, there's K. So K is here, okay? So whatever on the x. There's nothing added or subtracted, so there's no D, and then here's C. So what this y equals 4 is talking about is the asymptote, okay? So we start off normally our asymptote from yesterday's note, our asymptote is going to be 0 unless it's been shifted up or down. And here, because we've been shifted up 4, our asymptote comes up to 4, y equals 4. Okay, so you'll see that when we sketch them later on, we'll do the points like we did before with AKDC, and you'll see that the asymptote gets pulled up. It's got a vertical compression of a half, -1 here. There's a negative, so therefore reflected in the y-axis. Remember, y-axis is horizontal reflections. Here, a bunch of stuff. I have a -2, so there's my A. So my A is -2, so it'll be a vertical stretch of 2, and then flipped. A 2 here, and notice the bracket between the X and the the K and the D, which is great. So the K is 2, so horizontal compression by half. Remember, you need this is K, but what happens to K is 1 or what happens to the function is 1 over K. 1 over K is 1 over half. 1/2 is small, therefore it's a compression. Okay, hope that makes sense. D is -3. Again, you need to change the sign here, so it's x minus D. And just remember your vertex, right? If I had a vertex of this, right, back to our parabola, that if I said what's the vertex, you would say -3, -3. Okay, change the sign, keep the sign. So change this sign, so it's left 3, and then leave that sign, so we're there. Okay, so that's page 1. I get to page 2, so please flip if I can work my way down there. Page 2 now, what we're going to do is we're going to look at what happens when we apply a bunch of transformations to a base function. Okay, so again, you need a base function, and we're not going to memorize these. Well, you can, but it's easier not to. Y equals 2 to the x. You don't need to memorize them, is what I'm mumbling at here. Okay, so we'll get a series of points, and then we'll move the points depending on AKDC. So we start off with, we'll make it, really it's a table of values here. So we'll start with -2 as my x, -1, 0, 1, 2, and 3. And we can always do that. We don't need this this last section here. So -2 is my first point. -2, 2 to the -2. Remember, that's 1 over 2 squared, which is 1 over 4. And I'm not going to put the brackets because it's too many. It'll be a big mess here. And then this is 1/2, right? 2 to the -1. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4, and then 8. So those are my base points, and then I'm going to move them. So I look here. So my base function is y equals 2 to the x. So what have I done to y equals 2 to the x? I put a -2 here, a +1 here, and a -3 here. So there's 3 columns, so it's kind of giving it away here. A is 1, so we don't need A. We need K, we need D, and we need C. So K is -2. D is -1. Change the sign. C is -3. So what happens to each of these here? So K is -2. That will be a reflection. So we're going to reflect Okay, so I'll just do flip. This pen's a little big. Flips in the x-axis, and also k of -2, we do 1 over 2 as our transformation. Therefore, we have horizontal compression of a half. That's a D. D of -1 means left 1, and C of -3 means down 3. So how do we do the points? Remember, it's always x. First, we apply to the x, the y. Remember, this is y at the end. So the first and the last transformation are to the y's. The two middle ones are to the x's. We're missing the first one, so this is to the x, this is to the x, and this is to the y. This is down 3, this is left 1, and this is times -1/2. Okay, so leave your y's originally. Then we're going to horizontal compress and flip. So now I'm going to change all these signs and also make them half as big. So this is 1, half, 0, half, negative, -1, negative, let's use decimals here, 0.5, 1.5. So decimals are fine because we have a terminating decimal, and these stay the same, 0.25, 0.5, 1, 2, 4, and 8, comma, 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 chameleon. That's the joke. Left 1 means x minus 1. So there's x minus 1, 0. This should be a half. Negative a half now. -1, -1.5, right? -2, -2.5. And these stay the same. Remember, we take these y values, not these ones. Oh, they're the same anyway. But anyway, take the ones from the one previous. Okay. Anyway, 4 and 8, comma, comma. No more jokes. Okay. Y minus 3. I'm going to bring it down 3. So my asymptote now would not. So normally I'm here, and my asymptote is going to come down to -3 down here. Okay. So down 3. That's my y. So that's 0, -0.5, 0. No. Sorry, -1. Again, copy from the previous column, not from the one before it, like I did. -2, -2.5. And now these are down 3. So this would be -2.75, -2.5, -2, -1, 1, and 5. And then you go ahead and graph these. And then you get something that looks like this. Okay, so go ahead and sketch these points. I'm not going to do that short on time. So you go 0, 0, and just less than -3. So what you'll do is when you have your axis, you have to draw a set of axes here. When you have that, you'll notice that 1, 2, 3. There's your asymptote, and we can label that also. Okay, so you plot your points, and you get. Oh, actually, it'll go like this, right? Because it's reflected. Okay, so that's that. Go ahead and try the next page. Let's flip to the next page for a second. I won't because the answers are there. So go ahead and try the next page on your own. Actually, you know what I'll do? I'll show you. Don't look. Don't look. Hold on. Here we go. Okay. So here, let's go through it and see what happens. See if we can figure this out. Our base function now is 3 to the x. Okay. And what's happened to 3 to the x? I have a negative here, so that's going to be my a. So my a will be -1. I have a 0.5. Notice that there's a bracket here, so my k and my d are separated, which is good. That's 0.5. This is +2, right? Change the sign, and +3 at the end. So what happens to everything here? Let's go through what happens, and then I'll leave you and let you do this on your own. This is a reflect or a flip up and down. So flip it on the x-axis. Here I'm going to go 0.5 means 1 over 0.5 or 1 over 1/2, which means a horizontal stretch of 2. I'm going right 2, and I'm going up 3. Okay. So when you take your points, start taking your points, you apply all those things to it. Okay, this will be y times -1, x times a half, x times 2. So this is y times -1, x times 2, x plus 2, y plus 3. So we need our base points. Let's see if I can do this. Yeah, it worked. Okay, so our base points here are -2, -1/9. So in this case, you're going to be in trouble if you try to use decimals. Don't use them because these are not terminating decimals. 1/9 is 0.11. We know that. Okay, so I'm going to pause this after you get these points down. go ahead and apply all this. Actually, I won't pause it. Your teacher, pause it, please. So on the count of 3, could you please pause this as the students work through this over the next 6 minutes? You could play AC/DC in the background. Also, someone could sing. It's up to you. Okay, so pause now. Or sorry, I said 3. 1, 2, 3. Pause. Okay, unpause. Boom. What happened? Oops, nothing. Here. Okay, that's what happens. Okay, you apply all the stuff to it. So you can pause it again. Make sure they all get it at the count of 3. 1, 2, 3. Pause. And unpause. That was quick. I'm confusing myself. Now, when you graph this, just graph the points. You're going to get something that looks like this. Okay, so take the final points again. Just take the final ones. If your points don't fit, that's fine. Your last couple of points might not fit on the graph. That's fine, but you got this one and this one, this one, and this one. You get the general gist of it. You have y equals 3 as your asymptote. Because you've reflected in the x-axis, you're going down here. So it's still the asymptote, but if we did domain and range, you would have a range that is less than 3, not greater than 3. Okay, so anything that opens this way would be a domain of greater than 3. Okay, so let me move on, and we'll do the last one together. I think we will. Sure. So this is a bit irritating with the half as your base. So it's a half as your base. So you're looking at the k in this case, right? So half is your base. There's your 3. That's going to be a is equal to 3. So here a is equal to 3. K, I don't see a k. Okay, so my base is 1/2 or 0.5 to the x. We'll leave it as a half, I guess. 1/2 to the x. So there's nothing multiplying right on the x here. But the plus 2 is going to be your d is -2, and then you have a c of -5. So a is a vertical, so you're affecting the y. X, y, times 3, -2, -5. Okay, and then you're just going to work your way through this. Too many points here. I'll just do a couple because I'm old. So let's try -2. We'll get the base. We'll get this row ready, but I'll only transform a few points. So -2 is my first guy. I'll go -2, -1, 0, 1, 2, and 3. Again, you don't need these brackets here. I'll stop doing that. And you want 1/2 to all these things. So let's start at the bottom here. 1/2 to the 3 is 1/8. 1/2 squared is 1/4. 1/2 to the 1 is 1/2. 1/2 to the 0 is 1. 1/2 to the -1, you're going to flip it. So 1/2 becomes 2, and to the 1 is just 2, and this is 4. So the numbers are the same here, right? So 1/4, 4, 1/2, 2. We kept going to be 1/8, and that'd be 8. So I'll just do the first point and the last point, and you can do all this stuff in the middle. Okay, and then check off each other's work. Just make sure there's a pattern to it. I'm running out of time too. I'm at 13:20, and this thing runs out at 15 because I use the free version because I'm a little cheap. Okay, so y times -3. So there's your x, there's your y. -2, 12, right? So that's, oh, what's going on here? I forgot to say what's going on. This is a vertical stretch of 3. This is going left 2, and this is going down 5. Okay, so we can add that in also. So this guy's been stretched, and all these points get stretched, and this point here, 3, and then what's going up with this? 1/8 times 3, that's an easy one. 3/8. Okay, easy to add or to multiply. A little more difficult to add and subtract, which we'll do next. So d -2 means x, I'm going to the left 2, so my x values get affected by 2, so this becomes -2. Be careful here. -2 subtract 2 is -4, and 3 subtract 2 is 1. Just, you know, when you do this sort of thing, there will be a pattern to it. So this is -4, and then you'll notice, if you ever see, like, if your numbers go -4, -2, 4, 0, 6, you look at this and you go, oh, hold on a second. Something weird's going on here, okay? Whatever, I don't know what pattern's going on, but I'm getting more positive, more positive, more positive here, and then I get negative, more negative, okay? So you gotta be careful. If you see something like that, address it there. Okay, I'm almost out of town. So now I'm going down 5, so that's -4. 12 minus, that's 7. 1, 3/8. Mine is 5. I ran out of time.